Hi, everyone. Thank you very much. I mean, we're on that simulation track that we're doing in the last days. We heard a lot yesterday from different backgrounds, different visions, different angles on talking about what they were doing in simulation. We had the presentation from Red 6, very inspiring. We had also very deep diving from NASA on how they're representing the moon surface. And the moon's a bit far, and we wanted to talk to you about something different today. And I invited some friends who know things. And so in this session, what we want to do is to not maybe give you a recipe, but show you the state of the art, what's happening today, and what will be happening in the coming years, months, maybe in some cases weeks, in terms of geospatial content and how you can integrate them into your applications, no matter if you're building simulators, games, animations, movies. And so in this panel that we have here, we'll be demonstrating different things. So just to give you a little teaser of the realm of possibles today, all these solutions are not future solutions. They are almost old solutions now. They're all available in Unreal. Maybe have seen these on social networks. You probably have downloaded some of these solutions already. You may not know them all in details. And that's the type of things that we'll be diving in today to show you what's the vision, share the ideas and the trajectories of these visionaries of that field. So with me, you have Dan Nord next to me here from Maxar. You have Michael, who's with blackshark, Michael Foot. We also have Brady Moore from Cesium here. And actually, you know what? Even better. Look at them, they have pictures. We have David from Esri as well.
Seb, did you have to read my name?
No, I didn't.
Are you sure?
I'm sure I did.
Okay.
We rehearsed that one too. That's crazy, right?
Tell
That's the best
truth.
way to get other people to come in. Right. So really, in these sessions, it will be a conversation. So I won't hold the mic too often because I don't know nothing, but they do, and I'll be asking the questions. I'll be giving the answers, and at some point we'll get questions from you as well, and it will be magical. It will be a very good time. So without further ado, I'll start with our first questions on that topic, and I'll take my notes, and I'll read from my notes because sometimes you read from your notes. It happened to you once, right?
Read it from notes?
Never. So really, I mean, the first question that may sound very, very strange to all of you because some of you might know some answers that you have in that field, but why is representing the world such a useful use case in the digital environment, right? And really, that's a global question that's not related to simulation per se, but it's a global question that we want to ask, and figuring out, what is it that is so important there, and why is it such a key use case these days? And because I had to look at his name on the slide earlier, I'll ask David first to answer.
Oh, that was my gift. Thank you, Seb. So since the challenges we have today are really rooted in the real world, that's not really a huge statement. But in order to solve some of these challenges, we need real-world data. Regardless if the challenge is affecting all or most of us, it could be conflict, it could be socioeconomic problems, it could be natural or person-made disasters, or it could be more localized. It could be the problems that you're trying to solve at your business each day. But having a digital twin of the world that represents real data allows us to analyze these problems, come up with solutions that save time and money, and I don't want to be too dramatic, but depending on the application, perhaps even lives. So the examples that we're seeing with our customers using Unreal Engine and our technology is they are preparing, for example, for hurricanes, both before, by using simulations for first responders, simulations for the safe passage of people, evacuations, but also afterwards in the recovery effort. And then more probably locally, they're using the technology for urban planning. They're designing buildings in cityscapes and getting buy-off from their stakeholders. Or AEC firms are using technology to map out their construction sites to make it as efficient as possible. So I guess to answer the question, Seb, the reason why it's important is our challenges are rooted in the real world. And so having real world data in order to analyze and get all of the information and kind of this common operating picture is important.
Thanks a lot. Brady, do you want to give your point of view on that? Oh, and sorry. Yeah, and the fun thing in this story is that, as you can see the names of these companies here, you can understand that it's a domino game, right? There are dominoes, production of content, hosting the content and distributing the content. In some case, with what Blackshark is doing, augmenting the quality of some of the content, and that's why we believe here at Epic that this is an ecosystem that is very well chained, right? That's why in the answers that you'll hear, you'll have different point of views. There are different layers of answering to these questions. Thanks, Brady, go ahead.
Yeah, so to go off what Dave said, tons of use cases, but at the same time, tons of sensors out there. And the more we throw sensors on everything from phones to vehicles to, anything you can imagine, the more data we're having to deal with. For a digital twin, the value is going to be coming from being able to see all that in one picture. One. Two, where can you see that picture? Digital twins are going to be used for decisions. We make decisions everywhere. You don't just make decisions in your office, sitting at your laptop. You make decisions when you're seeing a simulation in a game engine. You see them on your phone. So one of the things we've been focused on with at Cesium with open standards is using open standards for interoperability. So that same data that you're looking at inside a geospatial information system is the same data you can bring and look at on your phone, look at in Unreal Engine across it. So interoperability is just a major focus for all this.
For me, it started this idea of having the entire planet as a digital twin. I think it was in 1999, 2000, when Unreal Tournament Engine 1 had been released, which is way before Unreal Engine 1, 2, 3, 4, 5, which we have right now. And back then we did a small portrait of our hometown for a World Exhibition 2000, which was manually building up the old European buildings and putting facades on it by taking thousands of pictures. And we dreamed of something like a device, Ghostbusters style, to scan the facades and get all the detail, which now is reality. But still, the entire planet was a challenge. It's way bigger than just a localized environment. And so, we need a solution for doing that at speed and scale. This is what we are offering. And then you mentioned the use case with urban planning and more the local context, high details. But there are use cases which are on a more larger scale, requiring less precision, like imagine giving you the solar capacity for every single building in the United States, which is a guesstimate rule by thumb value, but still very helpful. If you know the rooftop orientation, the angles, the neighboring shadow casters, like tall vegetation or buildings, and maybe some rooftop interruptions like furniture, like AC units or satellite dishes. So I think right now is this point. Myself made a career in game development prior to Blackshark. And for me, it was just a point in time when it will happen, that the real world and the digital world will converge. And I think we are there now, which is super exciting.
So Michael, if you started your journey in '99, mine was last year. So I was happily making games at EA and then making games at Amazon. And Maxar called. They said, "You heard of Maxar?" I said, "No." Like many of you here probably haven't heard of Maxar. And they said, "Have you heard of Google Earth?" I said, "Yes." Like, that's Maxar imagery. So Maxar, for the last 30 years, has been building satellites that take pictures of our world and take pictures in the highest resolution there is out there. So of course, the US government, allied governments, the military wants this kind of imagery. But it's been behind the scenes in the commercial world. So you all, if you use a mapping application to get here, you looked at Maxar imagery. If you were scouting an Airbnb, you looked at Maxar imagery. And this is the first time Maxar's been at a gaming conference. Of course, I've been to many. In fact, if you find them, they're either wearing jackets or uncomfortably wearing hoodies and being casual. But Maxar's, they called me and they said, we've been providing the 2D version of the world for the last couple decades. And so if you're at Esri's base map or you're looking at Google's base map, you see Maxar imagery. But the magic is that they've been taking images for so long, you had hundreds of petabytes, 100 plus petabytes of data. You can triangulate all of that and create a 3D version of the world. They said, we have a 3D version of the globe that's accurate to within a couple feet. And I said, that's the biggest video game canvas I've ever heard of. So I joined Maxar, and it's real. And so we've been creating this version, and we've got these wonderful partners that are bringing it out to the world. But it's not science fiction, it's here. We have a 3D version of the world that allow you to play anywhere, scout a film location anywhere. And you said save lives. It's absolutely saving lives out there, specifically in Ukraine right now. They have a full 3D version of Ukraine that we get to work with, and others don't.
Thanks a lot, guys. I mean, that's the trajectory, right? That's the use cases and the needs that we have. Now, the next question that we have for you today is really about this. I mean, you talked about the use cases, and I mean, these days are a bit special. There are a lot of things happening. There's a lot of convergence. We start to see a lot of conversations about simulation and these digital twins and how to make things that were digitalized, that were static, making them alive. And what are the types of evolutions that you've seen in the geospatial world, both in terms of adoption in different use cases and different ways of building pipelines, and also what are the changes that you've seen in terms of technology that are changing this ecosystem right now, and why do we have the four of you on the stage for the first time together? There's something special happening, right? And we like to understand it a little bit better, and I mean, we rehearse that, so I know the answers, but it would be good for the audience to hear from it. So let's start in the other order. Let's start with you, Dan.
Great, yeah, I think all the tech tailwinds right now are helping out this industry. The growth of cloud lets us do massive computation on massive pieces of data. In fact, Maxar was the first customer of the snowmobile for AWS. If you don't know that, that's instead of data transfer over Wi-Fi or cable, they actually drove a semi-truck to Maxar's campus, loaded all of the data on drives, and drove it back, which is ingenious if you think about it. It's actually faster to drive for 2 days than to transfer it. And so Maxar's been using cloud since, for the last 5 years, and just redlining CPUs, compute, GPU compute to create this 3D version of the world. Without that, we wouldn't get anywhere. And then rendering, specifically for the gaming world, rendering has gotten fantastic. So you can take a Maxar 3D version of the world, which it comes with 15 centimeter pixels. So like your phone is 1 pixel, so a car gets maybe a few thousand pixels. And you can do things like with Blackshark, you can texture it, make it look really good, and then Unreal can bring it to the world. So you'll soon be having global scale video games. So yeah, I think cloud, compute, and rendering are probably the three biggest. And then I think education, and that's where this is coming in. I mean, some of this tech's been around for decades, but I think gamers focus on one level, New York City only, because you can capture that with a drone. But when you start getting satellite imagery and then the satellite imagery integrators, you get global scale. So if you want to do a drag race on the demilitarized zone of North Korea, you can do that. That's the magic of this canvas that we're providing to the game developers in the room.
Dan, that truck had to have been the biggest thumb drive in the world.
Yeah, and actually we have a great satellite shot of it, so you can see it from space. That's how big the data is.
So I think the biggest transforming agent is technology. And just the example of the new flight simulator where blackshark provided the entire planet in 3D, the conceptual phase for this game or simulator started in 2016, and back then, it's a couple years ago, there was no Unreal Engine 5. So the people working at Microsoft on the game engine had to do their proprietary engine to enable the entire planet scale, like the double precision. We providing buildings and infrastructure, we had to develop our own streaming because this was not yet available in a commercial product or tool set. And now a couple years later, it's available. And now we can focus on what we can do best. We can make sure we transform information from 2D images, satellite images, into 3D, and we don't need to think too much about the streaming aspect anymore. Still, it's an issue, and you cannot stream anything because we use, as you said, cloud. We absolutely need the cloud to process and to detect and reconstruct the planet, but we cannot stream to everyone because, like in the flight simulator, hundreds of thousands of players are playing at the same time, and there is no bandwidth available to stream in the entire planet. So we again had to do our own procedural grammar language to compress, to deliver basically our content as code, which gets in streamed, but code has a less memory footprint than the actual pixels or geometry or textures. Then we conflate it in real time on the client and display it in 3D. So we are far not there where we want to be, but I think it's a very important step now having tools like Epic is doing.
At Cesium, I think that the biggest things that we've seen have been shifts from 2D to 3D overall for different use cases. Things that people were doing on a 2D map, just a couple of years ago, or they're now trying to do inside of a game engine. I think it's a massive step, and there's still a long way to go for that. Additionally, adopting things like, that come out of open standards like streaming, just people being comfortable with streaming geospatial data in general. The more and more that comes along, the more capabilities we see. And then personally, like the things that I see that kind of surprise me or impress me the most have been convergence of different worlds, like meaning that I'm seeing graphics developers, geospatial developers, and gaming developers converging all their ideas onto one thing at the same time. You don't see that too often. Even across a career, a bunch of completely different mindsets and viewpoints on how to create something and actually coming together on it on a platform like Unreal Engine, being able to do that, that's been pretty cool. It starts as a struggle, but usually ends up with something pretty good. And then the other thing that came out that really struck me is just speed of development, especially in simulations. We came out with the Cesium for Unreal plugin like a year and a half ago. Within a couple hours after releasing it, we were seeing global scale simulations from the community. And that just blew me away. It still does when I think about it. The ability to be able to create something really quickly through community engagement is astounding. And I'm sure I'll still be surprised by it the further along we go.
Yeah. So, it's interesting, Brady, something that you touched upon, something that Dan touched upon, and this is more forward-looking, so I'll get to the question in a moment, Seb. But you talked about 2D mapping and where we were 10 and 20 years ago. Where we are now with 2D mapping is 2D tiles are commodities, right? It's like air. We just expect to have them. We're not there with 3D yet, but we will be, and I think the amount of time to get there will be much, much shorter. I'll throw out, are we being recorded? I'll throw out I'm completely guessing, 5 years, let's say. But that's really what I believe. So we're seeing the same trends and patterns that we saw with 2D data some time ago. It's going to happen with 3D data, and it's going to be better for everyone. So Seb, just getting back to your question, I break it down into 3 areas, and the points in each one of those areas, my colleagues here have already made, which are great points. One is data. So because of the power of cloud storage and cloud computing, we're able to bring massive amounts of data through streaming, and it's accurate data. It's real world data. So that's the one. So Maxar does a really great job of that. Second is the analysis part of it, and blackshark, Cesium. We all have our different flair on the analysis. And I'm not just talking about a pretty picture. I'm talking about the picture. The visual is great, but what's behind it? What's behind the data, and how can we use that data to find an optimal store location, for example, or to, in a game scenario, warn a certain character when they're doing something or that they shouldn't be, or that they should be. So that's the second part of it. It's almost bringing that visual data to life. And then the third part, and Seb, I'm not just saying this, is the glue that brings that together. And honestly, for me, it's Unreal. It's Unreal Engine. So it provides an environment that all of you are already used to working in. And we provide the components of all of that such that you can use a common environment and bring your cityscapes to life, for example, without having to learn what a level of detail is in a map, for example, or some other spatial components. We take care of that. You develop and build in the same environment that you're used to, and so that's a big advantage, I think.
Thanks. Brady, because you're destroying the material, you'll be the first one to answer the next question. Don't laugh, we rehearsed that one too.
Did you not like what I had to say?
The microphone didn't.
Oh.
So really, there's a lot of trends that we see in terms of use cases, in terms of technology evolution as well, and very often we get asked by integrators, by creators of simulation, hey, what's the best recipe to create my terrain in Unreal? What's the best, is there a recipe to take all these great, content and bring it to life to my specific application? Here is my use case. Give me the magic recipe to work in Unreal and to work in that context to create my geospatial magic so that I can have my one-size-fits-all answer. What's the recipe ready?
So I think it's actually a pretty good question, because I was just recently having this discussion with my kids. I've got 3 kids from 5 years old to 9 years old, and the idea behind recipes is it depends on a lot of different factors. Constraints behind, like, what kind of ingredients do you have, what kind of skills do you have, and then also what are your tastes? What do you want to be able to do? Who do you want to be able to impress, right? And so going over that, just looking at everything that you have and everything you want to do, being able to mix and match, create the recipe that's right for your use case. In the case of cooking with my kids, usually the customer is my wife. But in your case, your customers have things that they want to be able to see and do, and you have a certain amount of things that you're good at and what you have access to. So everybody's recipe is going to be different at the end of the day. From what I see overall, I think the best innovations, or at least the most worthwhile ones, are the ones that we remember, are the ones that are about creativity, that come from being creative under constraints, right? Everybody's got things they wish they could do, they really want to be able to show and do, or maybe even have to as a matter of life and death. And when you're able to actually do something really cool within those constraints, or save a life within those constraints. I wasn't able to actually do what I wanted to do, but I tweaked this thing. I used an open standard, and I was able to be more interoperable with my data. That's what we want to be focused on with the different recipes you have. Enable recipes that allow you to do things with what you've got.
Thanks. Don't break that mic again. Michael, do you want to answer again to this one?
I think the simple answer is there is no recipe, no single recipe. Like in your case of cooking with the family, my kids and wife just make it different to be different than my recipe. But that's not a use case. But in general, like each use case, each vertical needs maybe its own sensors. So this already means if it's an optical, if it's a hyperspectral LiDAR sensor, needs a different recipe, different solution to get there. And so there's no one truth for all, but tying in what you said, I think standardization is the key word here. In order to make all this happen, we need to define common standards. We have interoperability and inter-exchangeability, and I think big credit goes to Nadine and the OGC, who are driving like the open metaverse standard forum in that respect. I think all of us joined there, and I think then everyone can do his own recipe, but we go for a common layer or for a common base.
Yeah. Yep.
Okay, next.
Yeah, I think recipe is a funny word when you're talking about gaming. I sat on the EA Greenlight committee for 5 years for mobile games, and if someone came in with a recipe slide, we knew that game was going to be boring. In fact, My apologies to the Zynga folks in the audience, but they went with recipes on social games and they got real boring real fast. So no, I think what we're providing is a new ingredient, and it'll let game designers think from a global scale. So instead of saying, oh, let's create something the size of one city, you can start with, okay, given a 3D version of the globe that's either real, which is what much of us provide, or reskinned to be medieval or alien, et cetera. That's where you can start from. And so we're providing this new ingredient for the game designers and the game developers to create new, cool applications. I mean, look, Pokemon Go kind of got it started with, here's global scale, GPS-enabled, okay AR, but you're out in the world actually experiencing our real world. So now you start taking that to the next level. So I think that's our ingredient that we're adding to the recipe. And then when you're trying to pick which of those global scale, you can pick what you need. So if you need high accuracy, that's the Maxar Precision 3D product. That's the one that is used by militaries and allies, et cetera. So that it doesn't look as good, but it's highly, highly accurate, the most accurate in the world. If you need it to look good, if you wanted to have textured buildings, et cetera, that's when you start looking into the integrators and partners. And Maxar and blackshark are building a 3D digital twin that's photoreal. We have a talk tomorrow. Oh, shameless plug for our talk tomorrow.
That wasn't a plug. You said no plug.
Talk about it.
Yeah, Brady and I are waiting for that, by the way. When's that going to be done? I agree that there is no recipe. We do see, though, patterns of success based on all the variables that we talked about just a few minutes ago, and we see templates that we can use. I would also argue that we provide many of the ingredients that you as creators can use to come up with your own recipes. I'm just building on the food analogy. So you guys are all brilliant developers. You're all chefs. Our job is to provide the components to you or the ingredients to you in the form that you're expecting, and also in the level of granularity, depending on your experience, what you want to do, many of the things that Brady spoke about earlier. And it's up to you to create your masterpiece, your meal. And I think that because you're all creators, I don't think that you would want a recipe from us. I really don't. You'd probably look at the recipe and same thing that, when someone came in to that green light meeting with you just threw it away, right? Just give me the ingredients, I'll handle it. You guys have built careers on this. Now there's patterns and templates that can help with that. So.
Thanks a lot. So, by listening to the four of you, it sounds like, problem is solved, and we know that problem is never solved. So, we released 5, we released 5.1, we're continuing in the evolution of our engine. The same thing is happening in all fields of technology. The minute you have the impression that you're done solving the problems that you have, you discover the real problems that were hiding behind it. And that's really what we want to dive in as well in these sessions, right? A soup of polygon is not an answer to the needs of the simulation field. We need to know what we're navigating on. We need to know what we're looking at. We need to understand the environment and to be very, very semantic about the environment. There's a lot of challenges ahead in the geospatial world, and it would be interesting at this point to hear from you about the upcoming challenges that you see, the things that you think that the walls that are not broken yet, that you're making sure you're breaking at this point. And you can stay on the breaking wall analogy thing, or you can do something else. Michael, do you want to start?
I think the biggest challenge, what we started with using optical sensors, and the output is like 2D images, like the ones from Maxar, which I think give you the best signal in terms of X and Y, like the flat dimension, like to identify a rooftop or some certain piece on the surface. I think that's the key. But still the height is missing, and photogrammetry would answer that, but it's not scalable and not at speed, especially in a global scale for a global digital twin. And so for us, the next big thing is like SAR, like synthetic aperture radar, which is amazing in height, like in Z dimension accuracy. It really sucks in X and Y, but combining that with the optical one, I think should give us a very, very interesting outlook, and then thinking ahead, using hyperspectral for material detection. And I think I just shared our roadmap with you. But that's right now, I think, our biggest challenge now, going from the optical to the SAR and then next to the hyperspectral sensor signal.
Do you want to go next then?
That's good. Your roadmap should reflect the problems that we're facing. I thought that building games with 200 people was the hardest thing, like the biggest challenge, until I joined a satellite company and toured the satellite facility. Building a satellite that's the size of this platform out of millions of parts by hand, and then getting it to space on a rocket and having it work on the first try because you can't fix it. That's hard. And so it was funny when you said, we're all used to 2D tiles. They're like air. It's like, well, there's a $100 million satellite. So part of what Maxar and what the U.S. government helps provide for the world is something like Google Earth. Flying satellites is expensive, but it's providing a lot of data that we're talking about gaming and entertainment right now, but it's also helping with climate change and deforestation and anything you can see at a global scale and process and understand, you can start fixing. I think the largest challenge for 3D is getting enough satellites up at the right cost to get refresh of the globe at a pace that can be really exciting. I mean, if you had a 3D globe that was refreshing every 15 minutes, you've got a simulation of the world. And then you can start making real solutions to problems. Because if you can simulate the real world as it is, then you can, figure out how to react to a terrorist attack or a natural disaster. And so I think that's going to be the big challenge going forward is, can we assembly line satellites at the level of resolution that Maxar has?
Thanks. Ready, you want to go next?
Yeah, so as far as the biggest challenge is, it's kind of twofold. The biggest one to think about up front, I think, is generally mindset when it comes to simulations and digital twins. We've been using maps in a 2D format since the beginning of time. I think it's something like 5,000 BCE, and now we're getting to a point.
They're air.
Right. Yeah. Exactly. Even though they're getting made by $100 million satellites, they're air, and they've been around a long time. Yep. Getting into a mindset of what's possible with 3D in simulations and digital twins, and then doing it is, from what I see, the biggest overall problem or challenge overall. I'm probably preaching to a room full of the choir here, but I think the tools in many cases have outpaced our ability to use them. I think there's a little bit of a gap here between what we can do and what people are asking for, which is great for us. It's great for everybody in the room. What comes along with that, I think, when we're talking about digital twins and simulations, is all the difficulties that come along with system integration and data interoperability. Getting stuff to move from one system to another and look right and everything like that. And in many cases, those can be human policy problems. They're not focused on products in many cases. A lot of these things are getting solved by open standards right now. So making all this stuff interoperate between different systems in a way that's really valuable to people, that'll be the most interesting thing. I think we'll be able to address those challenges once people realize, if I'm able to take my entire operation, visualize it all in one picture, take things out that I want to take out, put things in I want to put in, and run through processes at software speed as opposed to reality speed, my overall operation becomes a lot more efficient and effective. Once people realize that, and get their hands on it and kind of feel it as opposed to just see it, then I think we'll start to close that gap between what's possible with the tools we have now and what we're willing to do.
Yeah, I think it's that data wrangling that is actually our job. right? So we need to wrangle the data so that you don't have to worry about that. You worry about all of the other challenges that you have with the projects and the job that you have. So the big challenge for us is twofold. It's providing more analysis, whether it's presented as analysis or it's just, hey, I just need to get from point A to point B. Well, someone could argue that in and of itself is analysis, versus, hey, I just want to texture these buildings based on occupancy or some other variable. It's about bringing those capabilities to the game engine world in a way that makes sense to all of you. Not that makes sense to us, that doesn't do us any good, but in a way that makes sense to all of you. And part of that comes back to data. So far, we've been talking about the data that can be made available to you, but in many cases, for your applications, projects, scenarios, you might have your own data that you want to host in the same form and manner in which you're getting 2D and 3D tiles from Dan. And so you want to be able to do that very quickly, very seamlessly, very easily, without being a geographer, without having to get a degree in some other technology in order to do. And you want to bring that into your development environment the same way that you bring in other data types, except it's your data. It's your authoritative content. Now, I'm not talking petabytes of data all over the world, although you might have that. Typically, it's localized, or it could be global in nature, but it's typically, we're not talking about the sizes. It's something very specialized to what you're doing. And so for us, that'll be one of the challenges and things we're working on, roadmap alert, to bring to all of you. And Dan, I didn't mean to suggest that the expertise, see, it's because of Dan's expertise and his company's expertise in satellites that just brings this data to us, and we take it for granted, completely take it for granted. And I know you're going to do that with 3D data too.
What's funny, one of the ones that I took for granted, have you ever noticed Google Earth has no clouds? The entire thing, it's just cloud. That's not how it works. Actually, half of all satellite images are of just clouds. The world is clouds.
True, yeah.
Thanks. There's one point that you tackled here that I want to jump on a little bit of script of what we were planning, but data going one way to the simulation is something that we're establishing more and more, and seems to be almost solved at this point. Data coming back to the systems because they've been processed, because they evolved over time, because I left marks of a track on the ground, or because something detonated somewhere and changed something. These elements of deformable terrains have been like the dream of that community for a long time. What's the view that the four of you have on that? Deformable terrains, evolution of terrains, et cetera.
Sure. I mean, I think it comes as when you're going to make a game, don't hire 17 environment artists and make a city. Just don't start there. We've got every terrain you could have possibly imagined as a starting point. And I was at Amazon. We were making this huge game called New World, and call it tens of millions of dollars go into creating a game space. You don't have to do that anymore. Make sure you at least Google one of these four companies before you start on that journey.
I think it's about change detection mostly, like finding out where this detonation happened on the planet, if we don't know it yet. And this again needs many, many satellites to have like a real-time coverage of our surface, and maybe a sensor which is good enough and precise enough just to detect it. We don't need all the full quality for this change detection, and then use the common methodology, might be photogrammetry or whatever, to reconstruct what happened because of that explosion.
Mm-hmm. Yeah, I'd say change over time has been a big focus for a lot of people for a while, and I've seen a number of different ways to address it. I think probably the most interesting one, I think I was just talking about something like this last week, is just the ability to go back and forth between different states at different times and be able to fully understand that, and especially in the case of a digital twin, in order to be able to understand how the change happened and what it turned out like and in different stages overall. To be able, at the end of the day, you're trying to understand an event that happened in time. The time dynamic aspect is, for what I've seen so far, the biggest part of it.
Yeah, it's a really good point. Up until now, we've been talking about the here and now and providing the most accurate and the most up-to-date data. Well, what about those changes? Some of them are slow over time, evolutionary. Some of them are quite drastic, an explosion. Well, what about analyzing the befores and afters of that? So it's a matter of not just the current digital twin, like you were saying, Brady. It's about versions of that digital twin. But also when that data changes, it's about getting that data back into the services that you all use. If it's Dan's service, they take care of that. They do that. But what if it's your own data? It's about providing that scenario to allow you to update your own data, because your data changes over time as well, presumably. Some of it drastic, some of it very, very, very slowly. So,
You know, as I'm listening to his talk, Maxar's known a lot for the imagery, but not as much for our APIs. But we did a hackathon a couple weeks ago, and in just a couple days, a team took our APIs on change detection, 3D and 2D, and created a real-time map of Ukraine that showed the destruction from the day before. And so you zoomed out. The UI was terrible. It was engineering art for sure. But you could see red marks, and if you zoomed in, you'd find a building that was blown up, and then you could right-click and see what building it was. You know, was it a school? Was it a hotel, et cetera? And then you could zoom out. And it was a wonderful tool that was quickly created. And that's the kind of thing that once geospatial data is really easily accessible and understood, you can create things like that quickly. And that was just a few-day hackathon.
engineering art. I love that.
I was an engineer, so I can
You can say, yeah, right.
It was right passport too, yeah. So we heard a lot of things, and none of you wanted to give me a recipe. So thank you very much for coming. But what would be the one thing, the one trick, the one quick fix or quick idea that you would share with this room on how to start engaging or starting to work with the tools that you're making available, the ingredients that you're making available? There's no recipe. How would you recommend that people start with engaging with your group?
Try it. Tomorrow we'll release a data set in New Orleans. It's cool. It's 3D. It gets you down to street level. Give it a try. See what you like, and then give us feedback. This is brand new. Connecting Maxar to the gaming community is brand new, and so let us know. Does it work? Does it fit into the pipeline? What do you need changed? How many more satellites do we need? Things like that.
And go to your session.
Thanks.
Of course.
Yeah, they're doing a session. What time?
It's 10 o'clock tomorrow.
In this room. Michael.
So for us, would be cool here. Maybe it's not the right audience here and going more to the game developer side, but giving our 3D contextualized semantic output of New Orleans, which we might release tomorrow. And you can imagine you have a facade and you have a material map. This is a window, this is a door, this is part of the window, it's the border of the window. But it's in our still very Lego blocky type of quality, and now seeing this amazing Quixel Megascan library provided by Epic, and now having some bunch of world-class environmentalists taking our results and then augmenting it with their skill to see what's humanly technical state-of-the-art doable right now, then streamed in with Nanite without any polygon limitations. This would be super cool.
5.1 is bringing an experimental feature of procedural content creation that can be a very good way to complete what Michael just presented. Brady?
Yeah, I think probably just about everybody in the room has messed around or is actively using the Cesium for Unreal plugin. What might not know, right now the 3D tile standard is back at the Open Geospatial Consortium to be ratified as 3D tiles 1.1. So there's going to be a lot of improvements and capability for metadata availability, data transport, bandwidth efficiency, and runtime performance overall. I'd recommend you go to our blog. We've got a post on there that goes through all the different changes to the 3D tile standard, the updates, which are pretty extensive, and they're gonna add a lot to your capability overall. And what goes along with that also is we always add to the tutorials for Cesium for Unreal on our website. So if you haven't checked those out recently, they're gonna gradually, as the 3D tiles moves along, more capabilities are gonna be put into those tutorials so you can actually do the most you possibly can with the format.
David?
Yeah. Seb, I didn't ask, or you don't know that I'm going to do this, so I hope this isn't a no-no. How many folks in the room are using real-world data, or at least played with it a little bit within there? Okay, great. So it's quite a few, actually. That's a little surprising for me. That's awesome. So I think, you know, you're all developers. What's the best way to learn? You just do, right? You just do it. Whether it's, you know, using our plugin, Brady's plugin, get your hands dirty with it. The developer experience is excellent. And, you know, it's funny, you were talking about tutorials. Those could be like test recipes, right? Like just try the test recipe. Get your hands a little dirty, and then take your assets. Drop your assets in there and see what kind of stuff you can do. So really, it's just about getting your hands on the tech.
If some of you are creating interesting things with these technologies, we're interesting to look at them and to expose them during ITSEC, which is coming up very soon. If you want to share some content, if you want to illustrate some of your content and show it on the Unreal Engine booth at ITSEC, see Christina, who's in the room. Christina, in the back of the room. And she'll help you to bring your content to our content creation pod at the event. Now that we're done with this session, we still have a bit of time. And if you have questions, we're all stuntmen on that podium here. So any question, the mic is over there. Feel free to ask.
I'd love to get a digital twin of that piece of cake that walked in, that was here. Just, that would be fantastic.
Good morning. I've had the pleasure of actually working in mapping SDKs recently. One hurdle that I ran into, like for an example, I could look at my house and it's my outdated old crappy car from years ago, and I want the current image of that. In the not too distant future, how plausible would that be to like have, say, an engine hit the button to refresh that image and it sends it to me real time? Or even even beyond that, like how plausible it would be for me to actually take my phone, look up at the satellite and wave at myself from the ground floor like real time, or just refreshing something like that.
Where did you get your image?
I can't talk about it.
So the reason I bring it up is Maxar has a SaaS platform where you can get all 4 million square kilometers we take every day in real time. It's called Secure Watch. It's probably a little expensive if you just want a picture of your house. But we have APIs that go down to the house level, so you can get a single one.
Scary.
We've done some experiments in consumer, but it's, you know, I think we're a little ways away from there being enough demand. But what I found is if you search our archive, you can find like a photo of your wedding from 15 years ago from space, and those are, you know, that could be cool. But in the meantime, you know, just petition the folks who create the maps or the satellite imagery you use, and tell them they need a more updated map, because some of this is just demand supply. We sell a global 30 centimeter skin and close to a global 15 centimeter skin, but not everybody buys that. They buy something of lower resolution and provide it as the consumer platform.
Cool. Thank you.
Yeah.
Hi, I work a lot in synthetic data and training AI. So we generally use like all your data sources as a base, but then we want to augment that with other things, kind of more similar to blackshark. One of the main issues we've had is all of CG is going USD, but GIS seems to be going GL-based, GLB kind of things. Is there any plans on, what we would love to see is something like 3D tiles, but USD. Is that something that's like on the radar, or is it more because a lot of the client base for the more traditional clients for this data is more like web-based, therefore it's GL? Any sort of thoughts in that space for interoperability?
Yeah, I'd say, you're absolutely right. The question of GLTF or GLB and USD is something that's on a lot of people's minds right now. And I'd say that's why things like the Metaverse Standards Forum and OGC and Chronos all exist, and why Cesium focuses all its community focus on that area. So I can't share any roadmap with you, but just know that your concern or your ideas are understood and being thought about a lot.
I was about to answer. Yeah, we're all stuntmen on that podium, but asking, do you prefer GLTF or USD to that panel is a question we can't answer on stage.
Cool, thank you.
So this just came up to me. Is there a way, like everybody wants real time right now, but can we go back in time and let's say colonial Puerto Rico or something like that? Can we go back in time and get imagery? I know it's not gonna be from satellites, but an AI generated imagery from the past.
The good news is it can be from satellites. Our archive goes back 20, 25 years, and so you can search it and build what we kind of call a digital timeline, like a time machine. You can go back, but I think it's when we get to the processing level and the analytics to be able to take an entire 100 petabyte archive and rebuild logic from it and say, here's the actual impact of global warming. We're a little ways off on that kind of math.
Yeah, it's, Dan, it's a good point because we use your data. We provide it to our users in an app we call Wayback, and you could go way back. What we haven't done that we actually are considering is providing that Wayback feature within Unreal Engine itself. Now we've had that requirement a couple of times. The drum beat is starting to get a little louder on that, and it falls right in line with moving forward with the evolution of analysis. And so Dan has the data. It's up to us to expose that to you.
Thank you.
Yeah.
Thanks.
Hey guys, first off, thank you for coming and speaking to the community. So obviously there's a lot of availability, focus, and demand for data for cities, terrain, that sort of thing. Something might be a little more niche, but is part of the digital twin of Earth is undersea. And so I guess, is there any effort or focus for use of bathymetric data to kind of for undersea maritime applications? And what are some of the challenges? They seem maybe akin to some of the challenges that NASA has shared with their presentation for lunar visualization.
So with regard to bathymetric data, this is something that Cesium's been focusing on for a little while. We recently posted something on our blog about how TerraDepth is using Cesium.js in order to be able to visualize the undersea environment. I think we'll probably, something over, talking roadmap, this is something that we're going to be focused on. You'll probably see something from us over the next year or so, as far as bathymetric terrain. As far as lunar, I don't know. What's Maxar doing for lunar?
Nothing yet, but there soon will be satellites around Mars and the moon. I think right now, let's figure out the Earth. We live here.
I was just thinking the same, I was just thinking the same thing,
There's
right?
one thing that's important in your question is really the notion of hybrid source of data and how to merge this hybrid source of data and make sure that you have a model that is not only coming from only satellite imagery or or traditional maps or elevation surveys that we have, but actually merging these systems together and leveraging AI to augment it. And I think that's really where we're converging. What we see a lot of use cases is hybrid sources of data gathered together in applications.
Good, thank you guys.
Hey y'all, I gave you all the opportunity to get the plug question in, no donations, but got a question for you. I think we're in the sweet spot as an industry. Love to be wrong. Love the panel's opinion on this. I think sweet spot for geospatial in gaming right now is kind of that aerial, right? Flight Sim was a great example of that. I wasn't a part of the team. I'm not biased, but I'm super biased on the Microsoft side here in showcasing what that can do for realism. But then when you get to ground level, realism becomes very apparent that there's still that technological gap. What do you guys think about the timeline or the maybe tech debt or tech advancements we need to get that realism at ground level?
I think the biggest challenge with ground level detail is the amount of complexity we need to deal with. It's an exponential increase of complexity versus a bird view, like flight simulator, where we don't get to the ground. Now new use cases like eVTOL, like electrical vertical takeoff and landing, where it's drone helicopters need to take off and land everywhere on the planet. Usually airports for professional flight simulating, like CAE, they are manually done, like with artists. And because it's a very constrained environment, because there are a couple of thousand airports or more on the planet, you can hand model then, and at travel altitude, you don't care about ground level. Now, with eVTOL, first use case, you need to have ground level. And my feeling on that is the solution is in procedural creation. Because if you look at everything on ground level, from the carpet floor to some meadows laying in the wind, we need to approximate. I don't think it makes sense to measure that. So understanding nature and try to model nature and then animate and display it and giving the right materials might be the way forward.
But that's the goal. So, if Maxar takes us from top down, and then you can use drone or procedural imagery to get the next chunk from the last meter, we're going to get there. I think there's some challenges to getting that data at scale, but there's phones and there's drones and there's bots, and there's ways for us to absolutely get to that finished product. And so that is the goal. And we won't stop till we do it. We have one technology at Maxar, we call it precision 3D registration. What it means is we can take a live drone feed and we can feed it into our 3D globe, which is highly accurate, and basically stitch in a patch that's real. So a typical drone will be 5 meters off of reality. They're really inaccurate, but it can get co-registered in. And so if we keep patching with every data source, eventually we'll get to a full globe that's living and down to the last centimeter. For now, we approximate and we texture, which is fine for gaming. But if you're flying a drone and you need to know where a wire is, that's a hard job.
And that's where all these other sensors come in, like you were talking about, Dan. And when I mean sensors, I mean you've got billions of dollars worth of sensors, right? But you all have sensors as well. You have drones. But there's other sensors too. There's stream gauge, wind gauge sensors, and there's also moving sensors, telemetry, for example. I know we don't like to get followed and be followed, so we kind of turn that stuff off. But if you're in an environment where you can collect telemetry, that is yet another sensor to kind of build or to kind of fill the gaps from the bottom up. And so there are your sensors, there's also our sensors too, and we're not quite, as you've recognized, quite there yet, but we are trending very quickly there.
And another approach that we've seen working very well in that field is very local photogrammetry, right? Having a drone survey, running on a region, building photogrammetric data set. You all have heard about reality capture. If you didn't, you can search engine that. That will give you a way that Epic is providing to build your photogrammetry survey and get this type of data as close as you want from the ground. Ready?
Yeah, I'd say overall, Chris, the biggest thing is making it quick and easy to get all those different sensor data inputs, all that heterogeneous data into one picture, and that's the open standards approach.
Yeah.
I think historically, just going back in my own mind from my exposure to defense systems, that's always been the hardest part, is bringing in that stuff, getting it registered appropriately, getting it placed appropriately, and then persisting it or marking it and saying, here's where it came from, and here's the timestamp on it. If you want to update it, here's how to update it, making that simple. I think a lot of that is our goal in order to be able to make, at the end of the day, it ends up looking like probably a mosaic of different data sources over time. But I think that's the answer.
And the metadata is an important point that you made. Do you guys know each other? Chris?
All right, well, with that, we're at
Yeah,
time. And I want to thank you, everybody. Thank you very much for attending. I want to thank everybody here. David, I didn't read your name. Brady, Michael, and Dan for being with us today in this session. Thank you, everyone, for attending. If you have questions, let's ask questions outside of this room. There's another session starting very soon. So please vacate the not the building, the room. Thank you.